I'm David Stringer, and this is R-2000, the Better Built House. Over the course of the series, which is about the construction of energy-efficient housing, we've been looking at a variety of construction practices. In this program, we're going to look at something a little less conventional. Techniques designed to speed up the construction process without sacrificing quality, comfort, or energy efficiency. Recently, Oliver went to a couple of interesting places. He toured a manufactured housing factory, and he also went out to a site where some prefab wall units are being used in the framing. He took the TV crew with him, so over to Oliver.
This house was built in a factory. I'm at Royal Homes in Wingham, Ontario, and we're going to be looking at manufactured housing, ready-to-move buildings. I think you're going to be very surprised by what you see. Throughout the series, we've been stressing quality control. It's a very important issue because the better built house is precisely that. It's better built. Here we see the whole process having been brought inside. There are three reasons for that. We don't have any vagaries of weather, we have higher levels of efficiency on the line, and very high levels of quality control. We're going to be looking at this entire plan. But before we do, let's review what we were talking about in the last program, double stud construction.
Double wall construction addresses the basic principles of energy efficiency by reducing thermal bridging, by allowing for high levels of insulation, and by allowing for a continuous air barrier. The main components of the double wall are framed on the platform of the house. The interior load-bearing wall is usually framed with 2x4s. When the framing is complete, the wall is covered with a polyethylene air barrier and sheathed with plywood. The exterior 2x3 or 2x4 wall is fabricated over the sheathed section, lifted and attached at the top and bottom by plywood plates. An R-20 bat is then installed horizontally between the sheathing and the 2x3, and an R-8 bat is installed vertically in the outer stud cavity. The wall is then lifted into place. The total R value of the wall will be around 40.
I've asked Doug Kuyvenhoven to show us around his plant. Hi, Doug.
How are you doing, Oliver?
It's really a pleasure to be here.
Good to have you here.
Amazing operation.
Thank you very much. We try hard.
I want to start with a question that I suspect would make you angry. Not because I want to make you angry, but because I want an answer.
Try it out.
What's the difference between what you're doing here and a house trailer?
Basically, the house trailer or mobile home industry started as a trailer manufacturer. They started with trailers and built them bigger and bigger, eventually built them to the size of homes. Our industry, we started as a custom home builder and applied factory-built techniques to that. So we're using the same techniques, but we're from two different ends of the industry.
I think I understand that. How about components? I know that out in the field I'm getting more and more components, both in finish and in terms of entire wall sections. Do you do any components here?
We build the components, but we also assemble them. What you have on prefab housing, as it's often called, the components are shipped to the site, wall sections, trusses, and then assembled on site. We put it all together here. The product that leaves our factory is 90 to 95% complete. It's got the carpet, the cabinets, ceramic tiles, everything is installed and complete before it leaves the shop.
So your process, Doug, really eliminates all the vagaries that there would be on the site.
Oh yeah, we control all the costs. We have all the sub-trades under one roof.
I'm really looking forward to seeing this. Let's take a tour.
Sure, I've got an interesting way of showing you around the shop.
Have you got a license to fly this thing?
Not yet. We're working on it, though.
Oh, that makes me feel a lot more secure. Listen, what are the major advantages to doing this kind of work? This is a hell of a framing crew you got here.
Basically, by working inside, we're not held up by weather at all. We can do all things to close tolerances because we're using larger machinery and we're using steel jigs to assemble it. Another advantage that we have is bulk buying, and a third one is that we have continuous quality control on the line at all times.
I'm really interested to go down and look at each of these workstations one at a time. Can we do that?
Sure, we'll head over to the framing area next then. At this stage of the production, we do the insulating. You'll see the cross-section of the wall here. We use a 2x6 stud wall with an R-20 insulation. We apply the drywall first, which is actually backwards to conventional construction. Since we're indoors, we're not worried about rain and the weather elements. The poly vapor barrier is installed next, and the electrical roughing is done. Around each receptacle and box, we put a plastic bag with acoustical caulking, where the wires project down through the base plate, and they're foamed in, as well as the base plate is foamed in to give a complete seal.
Do you ever use aluminized back drywall? I've seen some in the plant.
Yeah, the foil back drywall, whenever possible to get it, we use it in place of the poly vapor barrier.
I understand. What's next in the process?
Let me show you.
Doug, this is an incredibly systematized process. What happens when these units now go out into the field? What kind of foundations do you put under them?
We basically put them on any kind of foundation. They'll go on a poured foundation, a block foundation, or even preserved wood foundations.
Really? What kind of a joint is made between this unit and the foundation?
Okay, down here at the bottom of the floor joist, basically what we do is before we set the house on the foundation, we put a layer of sill plate gasket. Then you have the sill plate, and then another layer of sill plate gasket to form the continuous air barrier right through to the trim joists.
And you supply those gaskets yourself?
Yes, we ship them with the home.
Now, we've talked in other programs about wrapping this header area using either Tyvek or poly to make continuity for the air vapor barrier. Have you done that?
Yeah, last year we used the Tyvek around the outside of the joist. What we ran into was a lot of times it was getting ripped on site. In theory it worked good, but in practicality we had problems with it. This seemed like a better, surer solution for us.
Perhaps as a result of the fact that it's an RTM. What happens when the two units now come together?
Okay, between the two units here, we use a 1-inch foam backer, and this is put on one half of the unit. We're actually at the marriage wall here. When the other unit joins up against, it squeezes against it. That continues the air barrier across from one unit to the other.
So that means that the gasket goes up the wall and then all the way across the ceiling.
That's correct, all the way along where the vapor barrier needs to continue across.
How well have you done in air pressure tests?
We've done several houses. The first ones we've done around a range of about 0.5 to 1.5, in that range, mostly down at the 0.5 range.
At 50 pascals of pressure?
That's correct, yeah.
Very impressive. Now, what's left after these units are married together to finish on the exterior of the building?
Okay, basically on site it's just like your standard residential construction. We'll put on cedar, vinyl siding, aluminum siding, or brick veneer, whatever the customer chooses.
And then of course you have to seal the shingles across the joint between the two units.
That's correct. The ridge cap is installed, it's nailed to the foundation, and everything the same as you would on a standard site constructed home.
And the two units are actually held together by being bolted through at the plate?
That's correct. The two units come together and we put carriage bolts through approximately on 3-foot centers all the way down through the middle.
That's it for the outside. What about the inside?
Inside you've got the marriage walls to join at the archways, and the carpet to vinyl or carpet to carpet joints to do just along the center wall. That's really all that's left to do.
Can we take a look at that?
Certainly. Let's go through and have a look.
Good. Nice kitchen, Douglas. We've also got a painted building. Everything looks to be finished, and we know about the marriage walls. What's left to do to this unit when you now get it to the site?
On site, we simply have to hook up the electrical and the plumbing, and the house is ready to move into.
Fabulous. All the plumbing is in the building. The electricals are already in the building. Do you have ductwork in the building for ventilation?
If it's on the R-2000 homes, we install an HRV unit in the basement after it's set on the foundation.
And all of that is already in this package?
Yes, that's correct.
My last question, how do you get this unit to the site?
We use specially designed floats that simply support the home and transport it out.
I'm really looking forward to seeing this. Can we take a look at that?
Yes, we certainly can.
Let's go.
Well, you can see that they're loading a house right now out there, Oliver.
Yeah, indeed I can. They're just taking the truck and backing it right underneath the unit, eh?
Yeah, they simply back it underneath, and it has its own hydraulic lifts where it actually lifts the house up off the stands, and then it's supported and ready to roll down the road.
Then they extend the mirrors, turn on the lights, and drive it away.
That's all it is. The escort truck out front, and away they go.
And that's it. There goes another unit. So here we are in the loading dock. This is the next one that's going to be shipped, and it's number 228.
No, Oliver, actually that's number 1,228.
That's quite a few houses, Doug. We've gone right through the entire plant. We're finally at the end of the process, really at the end of this segment of the program. Maybe you could summarize for us the advantages of this kind of housing.
Okay, aside from the energy efficiency that we've looked at, we've got speed of production. We're not hampered by weather at all. We've got improved productivity through the procedures that we use, and we've got tight quality control. Every stage of production is monitored very closely through our quality control.
Indeed. The next thing that I'm supposed to go out and do is look at some building components in the field, some componentized units. And I guess I got to leave quite soon, so I really want to thank you and all the people at Royal Homes for a very nice tour.
It's been a pleasure. Glad to have you with us.
Thanks.
Bye-bye.
On the shores of the lake behind me, a developer builder is setting up a series of units. The system that he's selected to use to do that is a prefabricated panelized system made in a factory. But unlike the houses that we've just seen, are not prefabricated entirely in the factory, but rather are erected in the field. These systems come in a variety of different forms. Some of them come with finish already in place on the outside, some with finish on the inside, some with finish on both sides. In this particular case, the builder has selected a system which employs the frame and the guts of the wall, but nothing else. Then the panels are actually put together on the site in the field. These systems have a variety of advantages. One of those advantages is that there's reduced thermal bridging across the unit. Because the foam is very carefully fit in between the wood members, we have extremely little thermal bridging as well as a suppression of convection currents inside the wall itself. Another advantage to these systems is the fact that the building can be put together in the field very rapidly, and the continuity of the air barrier is extremely good, provided the joints between the units are very well sealed. The difficulties with these systems arise when you try to put services into them, and we're going to be looking at that in just a second. I'm here with Doug Davey and Tito Meyer. Doug is the developer of this project, and Tito is the site super. Doug, my first question is for you. Why is it that you chose this system?
Well, we found that with the Kano system off Lake Simcoe here at Davy Point, the prevailing winds are very cold during the winter, and this system is with an R-2000 factor is one of the advantages we can pass on to the customer as a saving.
So does that mean that you're finding it a good marketing tool?
Yes, it is a very good marketing tool for us here.
And these units are selling well?
Very well, very well.
Tito, tell me, is it hard to put up?
Not at all, no. These units are put together on a simple basis of a spline and a tongue, and each panel fits into each other.
So this is the joint that's taking place in between the various panels?
Yes, it is. And it's, we found it a good system.
Are you doing anything to seal the panels at the floor?
Yeah, we run a caulking bead around all exterior bottom plates.
And that's what's giving you the seal there?
Yes, it is.
How about services? It's hard to put services in here?
No, the tradespeople have had no problems. There's a electrical chase left for the wires to go down to the boxes, and then when they're finished, we put spray urethane insulation back over top of these.
So any place where there's a hole, you're going to be filling that with urethane
That's
foam?
right.
Okay, I've got that pretty clear. What do you do about interior finish now? What goes on top of these panels?
There's a 6mm vapor barrier, polyethylene goes over, and then half-inch drywall over the whole surface.
I got it. Well, it looks like a pretty straightforward system. I'm going to have to mull this one over. Thanks a lot for your time, fellas.
Thank you.
Thank you.
Thank you very much.
Yes. So basically, I guess I have a final question for you. Did you like what you saw?
Yeah, I liked what we saw a great deal. There's a lot of quality that goes into those buildings.
And with that kind of construction, is it still possible to get the same levels of air leakage control and the same high levels of insulation?
Got to be careful where you're putting the components together, but the answer is yes, definitely.
Well, it's kind of promising. Something to look forward to in the future, I guess.
I think so.
In the next program, we're going to look at the openings in the building's envelope, the windows and doors. So join us next time on R-2000, the Better Built House. That's a wrap.